In this video, you will learn how to set up your BFPS-VRHSP 02 NextGen and get your first pulse. In the box, you will find your butterfly seeder and an RS-232 cable for connecting either to the PLB21 control unit or a PC via an RS-232 to a USB Type-A connector, which we will link down below. To observe your pulse, power, and trigger the driver, you will need an oscilloscope, a function generator for triggering the pulse, a PLB21 control unit or a PC, and a power supply delivering 12 volts at 1.5 amps. Now, let's set our power supply to the maximum voltage input of 12 volts and increase your current limit to 1.5 amps. Let's connect the cables now. You can go ahead and connect the sync output from the function generator, which you can connect to your scope. This will help you getting a clean pulse, which you can trigger from it later on with ease. Now connect a BNC to MMCX cable that will connect to the driver. Connect the current monitor output from the driver to your scope via the BNC to MMCX cable and set the channel to 50 ohm termination. Now connect the sync output from the function generator to the scope and set your scope to trigger from that channel. Let's set the trigger parameters on the function generator. You will need to set the voltage high level to 3.3 volts and a low level of 0 volts. Make sure that you are outputting with a 50 ohm termination so your set voltage amplitude is correctly applied. We will set a pulse width of 100 nanoseconds. This value does not reflect the actual pulse width of the laser diode. In our test, we will be triggering with a frequency of 1 kHz. Connect the power supply to the driver's terminals. The suitable cable diameter would be 1 mm squared. Now connect the MMCX cable from the function generator to the right connector and to the left the current monitor to the scope. Screw in the driver to a heatsink with 4 M3 screws. Connect the provided data cable to the optional PLB21 control unit, which must be purchased separately. While the PLB21 is not strictly necessary to operate the laser diode, it simplifies driver control significantly. We will cover PC control later in this video. You can go ahead and pause the video here and take a look at this connection diagram of the driver. So far, your setup should look like this. After powering up, the control unit will detect the driver and display its serial number. A prompt will then appear to download the unit's driver. Press F3 to confirm this. Once the download is complete, you will be prompted to reset the PLB21. After the reset, you will see the main menu. In this demonstration, we will be using a 966.5 nanometer butterfly laser diode with a max power output of 40 milliwatts and 1.4 volts forward voltage, coupled to an indium gallium arsenide photodetector with a maximum bandwidth of 5 GHz. It operates across the spectral range from 800 to 1700 nanometers. After soldering the laser diode, ensure the trigger signal is disabled before powering on the driver. If the trigger is enabled, the driver will automatically output a pulse to the laser diode immediately upon startup. In set point 1 on the PLB21, define your pulse width, current, Vref, and preload voltage. The power output of the laser diode can be monitored by the photodiode integrated into the housing. To do this, the voltage generated by the photodiode is measured and compared with a reference voltage, Vref. As soon as the conditioned photodiode voltage reaches Vref, a monostable multivibrator triggers a signal that is approximately 100 nanoseconds long, indicating that the desired power limit has been reached. Use the preload voltage to optimize the pulse rise time. Begin adjusting this diode-specific voltage at 10 volts, increasing it slowly until you reach the desired rise time. Set point 2 allows you to control the driver's operational features, including configuring whether the laser diode power is delivered automatically upon the presence of a trigger signal, and enabling or disabling the TEC and the trigger input. For temperature management, the TEC setpoint menu lets you enter the desired operating temperature for the butterfly diode in Celsius and displays the actual temperature reading. Furthermore, under TEC control, you can fine-tune the PID control parameters of the cooler and set the maximum current output of the unit. After setting your desired pulse parameters, go ahead and turn on the output of the signal generator. You can gradually increase the current via the PLB21 until you see your pulse on the scope. The signal that we are observing is coming via the photodetector on channel 2. We will now proceed with controlling the driver via PC. We recommend using H-Term as the serial communication software. The link for it will be in the description down below. To ensure proper driver control, you must configure the serial interface with the following parameters: a baud rate of 112,500, 8 data bits, 1 stop bit, and an even parity. Alright, let's break down how to use the command interface for the driver. First, the basic structure. Every command you send needs to be a command word, followed by one or more parameters, and must always finish with the enter key. The driver will then send back a response code to confirm the status. 00 means the command was successfully executed. 01 means the execution was unsuccessful, and if there's an error pending, the response will be 10, otherwise, it's 11. To start the text interface, you simply input the command, init, and press enter. Here are a couple of examples of how to set specific values. If you want to set the pulse width set point to 2000 picoseconds or 2 nanoseconds, you input S-width 2000 and press enter. And to set a new preload voltage of 35 volts, you input S-volt 350 and press enter. For more information, go over the manual under Controlling the Driver via the PC. In this section, you'll find all the necessary commands to control the BFPS-VRHSP 02 NextGen. We highly recommend taking a few minutes to look through the full manual. That way, you'll really understand how the driver works under the hood and feel totally familiar with it.